In section 7.5, we look at solving radical equations, which really means solving equations that have radical expressions. So for this, we'll need two rules. One rule is that if x and y are equal to each other, then x to the n power is equal to y to the n power, and this is true for any number n. And the other rule is that if you have the nth root of x and you raise that to the n power, you just get x. So the n power cancels the nth root. So as a quick example of solving a radical equation, let's consider the square root of x minus 2 is equal to 3. We want to solve for x, and to do so, what we need to do is cancel the radical. And so to cancel the radical, I'm going to take the equation, and using the first rule up above here, I'm going to raise both sides of the equation to the second power. Or probably more commonly, we would say we're going to square both sides. Now, the reason we're squaring both sides is because when you square a square root, those are going to cancel out, as the other rule indicates. And so what we get when we square both sides, on the left-hand side, we are left with just x minus 2. And on the right-hand side, we have 9. And of course, this means x is equal to 11. And this is our solution. Now, one thing about radical equations is you must check your answer. There will be times that you will find a solution that actually doesn't work. So in this case, to check our answer, we're going to take x equals 11 and we're going to plug it back into the original equation. And so if x is equal to 11, the original equation becomes the square root of 11 minus 2 is equal to 3. And this says the square root of 9 is equal to 3. And that is a true statement. So this answer checks out. It works. There will be times when your answer won't work. And there's a reason for this. The reason is pretty simple. The rule says if two things are equal, then when you square both sides, for example, they remain equal. However, you could have two things that are not equal to each other, such as 5 and negative 5. Those are two numbers that are not equal to each other. However, when you square both sides, they become equal to each other. So anytime you raise both sides of an equation to a power, you run the risk of creating solutions that are not actually solutions. And so the bottom line is, anytime you're solving an equation that involves radicals, you need to make sure you check your answers. Let's do some other examples. So for our second example, notice that we have a radical on both sides of the equation. This is not really a big issue, especially because the number 3 here is being multiplied to this radical. So what we can do here is we can simply take the left-hand side of the equation and square it. And likewise, we can take the right-hand side of the equation and square it. On the left-hand side, when you square the radical, these cancel out, and we end up with just x plus 7. On the right-hand side, we're not quite ready to cancel the radical because squaring a product means that you have to square each factor of that product. So we have to take the number 3 and square it, and we have to multiply by the square root of x minus 1, which also gets squared. And so when we do this, we end up with x plus 7 is equal to 3 squared is 9. Square root of x minus 1 squared is just x minus 1. But because this number 3 was multiplied to the entire radical, 9 here should be multiplied to this entire binomial here. So the important thing here is to make sure you keep the parentheses around the x minus 1. From here, we can basically just solve it. It's a simple linear equation. So if we distribute the 9 on the right-hand side, we get this. And then we can subtract x from both sides. And then add 9 to both sides. And when we divide by 8, we end up getting 2 equals x. And so we suspect this is our answer. But again, you must check. You don't have an option here. And so if we take x equals 2 and plug it in to the original equation, we get the square root of 2 plus 7 equals 3 times the square root of 2 minus 1. And I like to put a question mark usually when I'm checking the answer, because I'm really asking a question, are these equal? This gives us the square root of 9 is equal to 3 times the square root of 1, which says 3 equals 3 times 1. And this is in fact true, which means our answer, x equals 2, works. And so it is a solution. Now for the next one, you don't have two radicals involved in the equation. There's only a single radical here, but it's not by itself. We have this plus 3 here, and we definitely do not want to square both sides when we have the plus 3 here. It will make the process more difficult. So the first thing I want to do is isolate the radical, get the radical by itself. So I can subtract 3 from both sides. And this will give us the square root of 2x minus 3 is equal to x minus 3. And then from there, we can go ahead now and square the left-hand side, which will cancel the square root. But then we also have to square the right-hand side. Doing the squaring on both sides gives us 2x minus 3 on the left side. And on the right side, we have to multiply x minus 3 by x minus 3. Doing the multiplication on the right-hand side should give us x squared minus 6x plus 9. And then from there, you should recognize that this is a quadratic equation. Therefore, we would like to set it equal to 0. So we can subtract 2x from both sides, and we can add 3 to both sides. And that will give us 0 equals x squared minus 8x plus 12. And so from here, we just have to factor. And I'll skip the work on the factoring here, but the factors of 12 that give you negative 8 will be negative 6 and negative 2. And then finally, we set x minus 6 equal to 0, and we set x minus 2 equal to 0, and we get two possible answers here, x equals 6, and also x equals 2. And so from here, we need to check our solutions. And to check our solutions, we need to plug these numbers into the original equation. So let's go ahead and do that. So first, let's check x equals 6. And so to do this, we're going to plug the number x equals 6 into the original equation. That will give us the square root of 2 times 6 minus 3 plus 3 is equal to 6. This is the square root of 12 minus 3, which is 9, plus 3 equals 6. And again, we're asking a question here. And the square root of 9 is 3, and so this says 3 plus 3 equals 6, which is true. So x equals 6 works. Now let's check x equals 2. If you plug in x equals 2 into the original equation, you get the square root of 2 times 2 minus 3 plus 3 equals 2. And again, this is a question. And so the left-hand side becomes the square root of 4 take away 3 is 1, plus 3 equals 2. And the square root of 1 is 1, and so we get 1 plus 3 equals 2, which says that 4 equals 2. And we now know this is definitely not true. And so in this case, x equals 2 is not an answer. And we have a name for that. We call this an extraneous solution. So it's not really a solution. So what we need to do is go back to where we gave our solutions over here, and we're going to cross this answer out. So our final answer to this problem is just x equals 6. Okay. Sometimes people will write down x equals 6, comma, 2, and then what they'll do is they'll put a slash through the answer that is extraneous. And actually, I kind of like doing it this way because it shows you that you got two answers, but one of them did not work. Okay, so there are different ways to represent the answer, but this is commonly how it's done. Okay, so for number 4 here, it's pretty much the same idea, except that this time we have a cube root involved. And the main principle here is that if you're going to solve an equation that has a cube root, then of course the way you cancel a cube root is by cubing both sides. So we're going to raise the left-hand side to the third power, and we'll raise the right-hand side to the third power. The left-hand side looks complicated, but actually the cube root and the cube cancel out, and so we end up with just 12t plus 4. And the right-hand side, 4 to the third power is 64. And then from here, we have a simple linear equation that we can solve. And by now, hopefully this is very easy for you to solve a linear equation. And we get t equals 5. And I am going to put a check mark here to tell you that it does check out. You could take the time to check the answer if you want, but in this case, it does check out. All right, in problem number 5, it's a lot like problem number 4. You have a cube root once again, and so to get rid of this cube root, we are going to have to cube the left-hand side. But again, if you cube the left-hand side, you also have to cube the right-hand side. And so you're going to have the cube root of x cubed minus 7 to the third power. And on the right-hand side, we have x minus 1, which is also going to be raised to the third power. Now, be careful here on the left-hand side. You've got a cube root, and you've got a cube, and then you have another cube in here. This cube in here has nothing to do with canceling. It's the cube root here and the cube on the outside. So let me just show that. This cube root cancels this cube, and what you get left over from that is x cubed minus 7. On the right-hand side, we have x minus 1 times x minus 1 times x minus 1. And there's no shortcut here, so be careful, because sometimes what people will do is they'll take this third power and they'll just put it on the x and put it on the 1, and that's actually not correct. So we're going to go through and multiply two of these factors together first, and it doesn't matter which two you multiply. I am choosing to multiply the second two factors. When you FOIL that, you get x squared minus 2x plus 1. And then from here, we need to multiply out the rest. And so we need to do x times this, etc. And then -1 times each one of those. So it's a lot of multiplying. What we should get is x cubed minus 2x squared plus x minus x squared plus 2x minus 1. And then combining like terms on the right-hand side, we have a negative 2x squared and a negative x squared. That's negative 3x squared. And then we have a positive x and a positive 2x, which is positive 3x, and then minus 1. And this is a third degree equation, so we should set it equal to 0. I'm going to subtract x cubed from both sides, and I'm going to add 7 to both sides. This will give us 0 on the left-hand side. And on the right-hand side, we get a pleasant surprise here because those cancel out. And so we end up with negative 3x squared plus 3x plus 6 equals 0. Okay, so we now have a quadratic equation. Remember, when you solve a quadratic equation, one thing you want to do is you want to factor out any leading negative that you have. And so we can actually pull out negative 3 here, and that gives us x squared minus x minus 2. Now the reason we want to do that is because now this factors much more easily. And then finally, we can set each one of these two factors equal to 0, and we can solve those two equations. Now, you do not set this factor equal to 0 because there's no x in that factor. So we have two possible solutions, and then you have to check these solutions. And I'm going to show you the work checking one of them. So you must check. Let's check x equals -1. So we're going to plug -1 back into our original equation, which is right there. And so if we put -1 in here, we get the cube root of -1 cubed minus 7 equals -1 minus 1, question mark. So we have the cube root of -1 cubed is -1 minus 7 equals, and -1 minus 1 is -2. And this says the cube root of -8 equals -2. And of course, we know the cube root of -8 is -2. And so yes, it checks out. So -1 is a solution, and you can do the work for it, but 2 is also a solution. And so for this problem, you get 2 solutions. Okay, and just to be clear, I did not show the work checking the other answer, but you could do that on your own. All right, one more problem. We saved the best problem for last. So this last problem has 2 radicals in it. They're both square roots, which is good. But notice that the 2 radicals are separated by a plus sign. We don't want to square this. Squaring this would mean you would have to FOIL this. So when you have two radicals on the same side of the equation, you need to either add or subtract one of the radicals to the other side. So I'm going to go ahead and subtract the square root of x minus 3 from both sides. Basically what I'm doing is I'm just taking this term and I'm moving it to the right-hand side of the equation. And so this gives us the square root of x plus 5 is equal to 4 minus the square root of x minus 3. Now from here, I am going to square both sides of the equation. And when we do that, the left-hand side is very simple. We simply get x plus 5. And the right-hand side, this part, this is going to be more complicated. We have to multiply 4 minus the square root of x minus 3 by itself. You cannot simply square each one. That does not work. So we have to take our time here. If you make a mistake, it is likely on this step right here. So we're going to FOIL 4 times 4. That gives us 16. And then we have 4 times negative radical x minus 3. That is going to give us negative 4 radical x minus 3. And then we have negative radical x minus 3 times 4, which is once again negative 4 radical x minus 3. And finally, we have negative radical x minus 3 times negative radical x minus 3. That's going to be positive radical x minus 3 squared because it's multiplied by itself. Okay. Now on the left-hand side, we still just have x plus 5. So what ends up happening here in the next step is two things. Number one, these two radicals are like terms, and so they can be combined together. Negative 4 of those radicals and another negative 4 of those radicals will give us negative 8 of those radicals. And then the other thing we can do here is we can cancel the square root with the square. And so what we end up with there is positive x minus 3. Okay, a couple more things here. Let's go ahead and combine like terms. 16 minus 3, those combine to give us 13. Minus 8 square root of x minus 3 plus x. Don't forget the plus x there. And then from here, what we can do is we can actually subtract x from both sides. And this gives us 5 equals 13 minus 8 times x minus 3. And I'm going to do something maybe a little bit unconventional here. I am going to take this term and add it to the left-hand side. So that becomes positive 8 square root of x minus 3. And then the 5 that is here, I'm going to subtract 5 from both sides. And that gives us, on the right-hand side, 13 minus 5 is 8. Okay, so I hope that makes sense. I'm basically adding 8 square root of x minus 3 to both sides and subtracting 5 from both sides. And I do that because moving the 8 radical x minus 3 to the left-hand side turns the negative 8 into a positive 8. Now from here, there's a couple of ways you could do this. You could just square both sides right now, but notice that we have an 8 on both sides. Let's divide by 8, because these will cancel out. And that gives us the square root of x minus 3 equals 1. Okay, so pretty involved problem. Remember, we had 2 radicals involved. We squared both sides. Squaring both sides got rid of 1 radical, but this radical is still here. So now what we have to do is square both sides again. So square the left side, square the right side. Squaring x minus 3 in a square root gives us x minus 3, and squaring 1 gives us 1. And then if we add 3 to both sides, we get x equals 4. So this is our answer, we hope. And then we have to check that answer. And so if we check x equals 4, plugging it into the original equation, remember the original equation was the square root of x plus 5 plus the square root of x minus 3 is equal to 4. So we're going to plug that in there. This will give us the square root of 4 plus 5 plus the square root of 4 minus 3 equals 4, question mark. And so that's the square root of 9 plus the square root of 1 equals 4, which says 3 plus 1 equals 4. And so yes, it checks out, which means 4 is our answer. So the big thing that I can tell you here in regard to this section is that, first of all, when solving an equation that has radicals, you want to make sure the radical is by itself before you square both sides or cube both sides. And the second thing is, when you're all finished, you must check your answers, because sometimes the answers that you find are not going to work. All right, so that concludes this section.